So I want to continue from where we ended, finding the charge on cation. So first of all, we have to find the charge on cation using the anion. So that's why from the anion we know that the total anion charge is -4. So the total positive charge is +4. But since we have just one titanium atom, 4 divided by 1 is 4. So the charge on titanium is +4. With chromium, here we have 3 oxygen and each oxygen is -2. So -2 times 3, the total charge of negative charge is -6. So this chromium, the charge will be +6. In this other situation, we have 2 nitrogen. And nitrogen is -3. -3 times 2 is -6. So the total positive charge, because an compound must be neutral. So we divide it by 3. And the charge on the ion is +2. So after you've known the anion and you know the charge on the cation, now you can now write the name of the anion and the cation, and you can combine it to get the name of the compound. So naming binary ionic compounds with variable charge methods. So here we have this compound. We want to use that. So identify the cation and the anion. The anion is F-, it's in group 7. So the cation is copper +2, because we have 2 minus charges from this to F-. So the name of the cation, because of this, is copper 2+. The name of the cation, the name of the anion is fluoride. So the name of the compound is the name of the cation first, then the name of the anion. So the name becomes copper 2 fluoride. So what is the name of this compound? We'll do the same, we'll go through the same steps. Identify the cation, but we identify the cation and the charge on the cation by using the anion. So the anion is Cl-, because it's in group 7. And there are 3 of them, so the charge is -1 times 3. So which is -3. That's the total charge, total negative charge. And because the total negative charge is -3, the total positive charge will be +3. So when you get the total positive charge, then you look at the cations, how many atoms are there, and you divide the total positive charge by the number of cations. In this case, we have just one, so Fe is +3. So the name of the cation is ion 3, and the name of the anion is chloride. So the name of the compound is ion 3 chloride. So try and do this. I think we did this. We just did this. But let's do this. Name of the following compound. So we just did this. Let's try and do this. So the anion here, anion, equals to Br minus. We have two of them, so the charge is 2 times minus 1, which is minus 2. So the total charge is minus 2. Then the cation, because the total charge is minus 2 and a compound must be neutral, so, and we have just one atom of lead, so this is Pb2+. So what is the name? Name of Br? Br minus, its name is bromide. And this is lead 2 ion. So the name of the compound is lead 2 bromide. We can write this too. This one, Cl minus, we have 4 of them, minus 1, minus 4. That's the total charge. So the name, then this, so this is chloride, because this one is chloride. So this one is S2 minus. So minus 2 times 3 equals to minus 6. Positive charge is plus 6. So plus 6 divided by 2 plus 3. So Fe3 plus goes to ion. Then S2 minus. Name of compound. So please practice more of this. Okay. So let's continue. So I want to write the formula of binary ionic compounds containing variable charged metals. So I want to start with this. Manganese 4 sulfide. Because in naming a compound, you should be able to know how to write the formula from the name. Or when you have the formula, you should be able to come up with the name. So to do this, you write the symbol of the cation and its charge first. So that's the symbol of the cation and its charge. Write the symbol of the anion and its charge. That's the symbol of the anion and its charge. Switch. So we want to switch. We want this to come here. And you want this to come here. Make sure you leave the sign, the charges. So this will be 4. And this will be 2. That's what you get. reduce. So reduce to the smallest whole number ratio. So divided by 2, divided by 2. So you're going to get that. So check that the total charge of the cation cancels the total charge of the anion. So total charge on the cation is +4, anion is +4. So you see they cancel. +4 minus 4 is 0. So please just do this, practice this on your own at home. It's a practice, try and do that. So I want to look at compounds containing polyatomic ions. Polyatomic ions are single ions that contain more than one atom, often identified by ion in formula. Name and charge of polyatomic ions do not change. Name any ionic compound by naming cation first, then anion. So we are going to look at some polyatomic ions and their names. So you see this chart, please, you need to know them. But what I want to highlight here is that if you notice, almost all this table, there is only one polyatomic cation. That's one thing you have to know. And if you look at this table of these common polyatomic ions, their names end either with ATE or with ITE. You have just a few exceptions. So it either ends with ATE or ITE. I want you to take note of that. Except you have some exceptions like hydroxide and cyanide, but all of them, look at this table. Go and look at it again. You see that the names end with either ATE or ITE. The difference between the ATE and the ITE for a group, I want us to look at this group. The difference is only oxygen ion. ATE in each group has one oxygen ion more than the ITE, polyatomic ions. But the charge is the same. The type of atoms and elements are all the same. So patterns of polyatomic ions. Elements in the same column form similar polyatomic ions. Same number of oxygen and same charge. So for example, this is chlorate and this is bromate. So you have to take note of that. If the polyatomic ion starts with hydrogen, add hydrogen as prefix before the name and add 1 to the charge. So you see, this is a carbonate. Its charge is minus 2. But if you add hydrogen here, the charge changes to -1 because you have added 1. -2 plus 1 is -1. And the name changes to hydrogen carbonate. Take note. I want to do another example. SO4, 2-. This is sulfate. HSO4 -1. This becomes hydrogen sulfate. So that's what we mean. So patterns of polyatomic ions. So you see, this is group 3, borate. Group 4, we have carbonate, silicate. Group 5, we have nitrate, phosphate, arsenate. Group 6, we have sulfate, selenate, tellurate. Group 7, we have the chlorate, bromate, and iodate. Patterns of polyatomic ions. Chlorate ends with ATE. ATE ions +1 oxygen, same charge, pair you just add the prefix. So if I add one oxygen atom here, the charge will still remain the same. So it will become ClO4 minus. So the name now, I'll add perchlorate. If I minus one oxygen ion, the formula will become now ClO2 minus. See, I am minusing it from this. So now I will change this name ATE to ITE. That's what I'm talking about. So you see, the name will change from ATE to ITE. Then if I remove two oxygen atoms, I'll change this name from ATE. We are removing it, take note, we are removing it from here. The name will change to hypo. I'll add hypo in front of the name. Then I will change this suffix to ITE. So that's how the name will become hypochlorite for this. The same will apply to bromine. The same will apply to iodine. So let's see how we can name ionic compounds containing polyatomic ions. Identify the ions. That's the first thing you do. For example, we want to do this. So identify the ions. The cation is this from group 1, and the polyatomic ion is this. Name the cation. The cation, invariant charge, the cation is sodium. The anion is sulfate. The name of the compound is sodium sulfate. The name of the cation plus the name of the anion. Let's take another example. Now we want to do this. Identify the ions first. The anion is nitrate polyatomic ion, and the cation is this. Name the cation, ion 3. Name the anion, nitrate. Name of the compound, ion 3 nitrate. Let's see how we can write formula of ionic compounds from the name. So we want to use ion 3 phosphate as our example. So write this symbol of the cation and its charge. You see the cation first, ion 3. So its symbol will be, that's a symbol. Write the symbol of the anion and its charge. That's the anion and its charge. Switch without signs of each ion to become subscript for the other. So we switch, so this will become 3. Put parentheses, this become 3. So that's what you're going to see. But you see, this 3 divided by 3 divided by 3. So now this is the formula of this ion 3 phosphate. So check that the cation charge is equal to the anion charge, so they can cancel out. So plus 3 minus 3 will give us 0. Some ionic compounds hide water molecules in their structures. So how do we name those ionic compounds? Hydrates. Hydrates are ionic compounds containing a specific number of water molecules for each formula unit. Water of hydration often is driven by heating. So when you heat it, you send it away. In formula, attached water molecules follow the formula of the compound. So this is the formula of the compound. This is the attached water molecules. You put a dot, then you put it. In naming, the attached water molecules is indicated by prefix to show the number after the name of the ionic compound. So for example, this is cobalt 2 chloride hexahydrate. And this is copper sulfate hemihydrate because it just have water molecule. So the prefix that we use are hemi for half, mono for 1, di for 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8. Those are the prefix. And you can see that the presence of water molecule changes the compound, even the color. Look at it. This is the hydrate, the hydrated form. And this is an anhydrous where the water has been removed by heating, as we said. Let's take an example. Write the formula of magnesium sulfate heptahydrate. We want to write the formula. So this is magnesium, the cation, this is sulfate. So its formula, this is its formula. But it has hepta, 7 water molecules. So what do? You put a dot, you put the 7 water molecules. So that's the formula. So let's look at this. We want to name it. This time we have the formula, we want to name it. Make sure you get the cation and the anion and get their names. Then you put the prefix of the number of water molecules present. Then you put hydrate. So this is the anion and this is the cation. So it's nickel 2 chloride. Then we have 6 water molecule, which is hexa. Then water is hydrate. So this is the name of this compound. So we want to learn how to write names of binary molecular compounds. So we have done ionic compounds. Now let's look at a molecular compound. To write the name of molecular compounds, write the name of the first element in the formula. Use the full name of the element. Then write the name of the second element in the formula with an IDE ending. So write it as if it were an anion, a monoatomic anion. But however, don't forget, remember that molecular compounds do not contain ions. They do not. So use prefix in front of each name to indicate the number of atoms. And don't forget again, the prefix mono cannot be used for the first element. So if we have to name a binary molecular compound, put prefix, except that you will not put mono. You can put di, you can put tri, any other one, but not mono for the first element. The name of the first element remains unchanged. Then you put prefix to determine the number of atoms of the second element. Then you write the base of the name of the second element plus IDE. So let's look at the prefix. When you have just one atom, prefix is mono, not used for the first non-metal. 2 is di, 3 is tri, 4 is tetra, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, deca is 10. So drop last A if name begins with a vowel. So we'll take some examples. Let's name this compound. The name of the first element is boron. The name of the second element must end with IDE. So fluorine is changed to fluoride. Fluorine to fluoride. Add a prefix to each name to indicate the subscripts. Mono, boron, trifluoride. Then drop the mono for the first element, drop it. So this is the name of the compound. Let's name these ones. The first element, the name is, sorry. So we want to name this, name the following element. So the first element is nitrogen, but we have two, so it's di-nitrogen. Oxygen, we have 4 of them, so it's tetra. But the name of the last element must end with IDE, so oxide. But you see, we have 2 vowels here, so we are going to modify the name to be dinitrogen tetraoxide, because we have to drop 1 vowel. So this one, we have phosphorus, just 1, we are not going to put mono, penta, oxide, we are dropping the A. Then this one is iodine, diiodine, heptafluoride. So you see we have 2 vowels, so we are going to remove this. Diiodine, heptafluoride. Please make sure you practice these things. So let's take another example. Binary molecular compounds. Now we want the formula from the name. So dinitrogen, it shows that we have 2 nitrogen. Nitrogen and oxygen, those are the elements present. Write the formula using prefix. So di2, 5-penta. So N2O5. This is the formula. So please make sure you practice this at home to write the formula from these names. So make sure you practice to write the formulas from these names. So we are going to stop here for now. We'll continue later.